This is Flappy Bird Day 3, and let's review Day 2 material. So first, when you run Flappy Bird, here's the functionality that you should have so far. When you press run, the up arrow will boost Flappy Bird upward with a certain velocity we called boost speed, and also Flappy Bird's angle depends on his velocity. So the faster you fall down, notice how his angle changes to a steeper and steeper angle as he falls down. A second thing we've added is when Flappy Bird goes beyond the edge of the world, then it's game over. We stop the game, we'll display the game over symbol. So that is the functionality we have so far. Today we're going to add this. We're going to add pipes and collisions. So first, we need to add an act method to the world so that the world can take part in the program. So currently, if you open Flappy Bird has an act method, and this is what happens every time there's a frame of animation. This code runs over and over and over again. That's what makes the animation. So we're going to add the same method to the world, because the world can also act. So back here, open up your Flappy world, and so far we have one method. This is the Flappy world constructor. This is the function that builds the world. Well, below this, we're going to add an act method. So paste this in, and make sure that when you paste it, you have an opening and closing brace. So it's public void act, empty parentheses, then an opening brace, and a matching closing brace. Make sure you have the direction of the braces right and the syntax correct. And you may want to just compile to make sure it works. Since it's compiled, that means I have the syntax right. Alright, now what we want to do is every 100 act steps, we want to just print out something. So first let's make a counter for the number of act steps. So int counter equals 0. This will be a global variable that just counts steps. So there's that. Down below, every time we act, we're going to increase the counter by 1. So counter plus plus will increase the counter by 1. And for now, let's do system.out.println just to see that it actually is working. So we'll print out the counter. This is just kind of a check to see that it's working. So we'll compile this. Go through my little Apple window. This is the console. I need to resize the window so you can see things, otherwise you won't be able to see this. Alright, when I press run, watch what happens. Did you see that? We started the counter at 0. It didn't print out 0, but when it changed to 1, then it started printing. And this is the world counting act steps. So what we want is, every 100 act steps, we want to make a pipe in the world. That's going to be our goal. And for now, we're just trying to get the basic functionality to be set up for us. Alright, now let's do this. Let's only print out the counter at step 100. So increase the counter. Then let's say if the counter is equal to 100, then we print it out. And also, in addition to printing it out, let's reset the counter. So counter equals 0 again. That way what this code will do is it will increase the counter until it gets to 100, then it'll print out the current counter of 100 and reset the counter back to 0. So the counter goes up to 100, back to 0, up to 100, back to 0. So let's run this and see that it's going to work. Clear out the current information there. And here it goes. There, 100. And there's 100 more. So it's printing out 100 every 100 act steps. And what we're going to do in a bit here is every time this fires, like now, we want a pipe to appear on the screen and scroll by. That's going to be our goal. So let's get that going. Back to the PowerPoint for our guide. Alright, if you want to add a pipe body every 100 steps, first we need to make a visual actor that is a pipe. So back here, let's right-click actor, choose new subclass, let's call this pipe, and go back to your import from file and choose wherever you downloaded the images from. It's called pipe body full. This is a full-size pipe that's the same height as the world's. Alright, there it is. So we have the availability to make a pipe now in the world to actually make one. So every 100 act steps, we would like to make a pipe. So I'm going to put a comment here. Create a pipe object. And here goes that. So to create any object, it's kind of the same syntax. We already made a Flappy Bird before. That was right here. The syntax for making a pipe is the same thing, except for the type changes from a Flappy Bird to a pipe. So the syntax is pipe, name it what you want. Let's just put pipe equals new pipe. Done. That creates one. Remember, this is the class type. The type of object it is a pipe, and this is the variable name. It can be anything. I'm going to call it Pippy, just to make sure you understand. This is a variable. It can be named anything. So we have a pipe named Pippy. Cool. And now we need to add Pippy to our graphics screen. So we can use the add object command. Add object. We're going to add Pippy to, let's put him on the far right hand side. How about get width? That's the far right of the screen. And how about the very center of the screen? Get height divided by 2. That'll be vertically centered. I'm also going to comment out the print line. Let's just delete it. We don't need it anymore. Alright, let me clean this up. So, cool. So let's just see if this works in the first place. So every 100 act steps, we should see a pipe pop up. So here goes. There it is. There's a pipe, and there's another one. Now it's on top, so you can't see it, but every 100 steps, a new pipe is appearing. Alright, next step is to make these pipes scroll over. So that is in the pipe code. Open that. Let me resize my window so we can see this easier. Give me just a sec. Alright, there we go. So in the act method of pipe, what does a pipe do? Well, a pipe, all it does is automatically moves left. So that's the functionality we need to program into the pipe. So let's go there and do that. Alright, so we go here, and let's say set location. Now pipe wants to move left, so let's get the current x coordinate and subtract, say, 4. And then for the y coordinate, let's just leave it alone. So this code here is going to say every time the pipe goes to act, we're going to basically move the x coordinate left by 4 by subtracting 4 from the current x coordinate, and we're going to keep the y coordinate the same. That should slide the pipe left by 4 every act step. And so let's check this out. So that version is thin, and there you go. There's a pipe. No collisions so far, but we have pipes popping up every 100 act steps. You can always change that to a different number if you'd like. So our basic functionality is working. Cool. Next, let's go back here. Well, first of all, let's get rid of this number. Remember, we talked about magic numbers. You don't want numbers just kind of floating in your code mysteriously. Let's make this into a variable called pipe speed. Capital pipe. Alright, pipe speed. And I'll define it up here as a global variable. Integer. Hang on. Okay, integer pipe speed equals -4. This is much better and cleaner code. That way you can change this in one spot rather than down here in the main body of the code. So there's that. Okay, next, make sure it's still working. And oops, I said I think the wrong direction of 4. Okay, I got it. That should be 4. 4. Let's go with this. Let's say it's -4 and then here put plus. So it's going to be the same thing. We're going to add -4, which effectively moves it left. So again, make sure it works before we move on. Alright, cool. So it's adding -4 to the pipe's x position, which is moving it left. Cool. Now let's move the pipes to the top and say right at the middle. So it's really a math problem, to be honest with you. The pipe's height of the image is currently, let me use my rectangle tool right here. This value, this is the height of the entire pipe image. So remember, Greenfoot uses the center of the objects using the center to draw in. So there's the center of the object. We want to move this center down here, basically half the height of the entire pipe. So how do you find the height of a pipe? Well, here's how. Let's look at the actor function. Inside of actor, let's look for a function that finds the height of an actor. Let me again resize my window so we can see this. So with actor, how can we find the height of an actor? Act, get image, get object, get world, get x, get y, but that's not the height, that's the y coordinate. There is no get y. So what do? We gotta do this. It's a two-step process. You have to first grab the image out of the actor that returns its image in this form. Then, once you have a Greenfoot image, it is what you tell to get the height. So there is a get height right here, and this is something that a Greenfoot image can do. So we have to do a two-step process. First grab the image, then ask the image to tell us its height. So I'm going to do this in two steps. And here are those two steps. Alright, before doing this, I'm going to say, let's go to the Actor API so I can show you what I want to do. I'm going to use getImage to return a Greenfoot image. So here goes this. Now since this is an actor function, you just have to say it straight up, getImage. So I'm going to say getImage. And then this returns what? It returns a Greenfoot image type of thing. That's the object type. So I'm going to save this into a variable of that type. So Greenfoot image, I'll call it image equals this. Check. So I've used the actor's capability of grabbing its image and stored it into an actual image object. Now we can ask the image questions like, hey image dot, what's your height? So here we go. To move this y coordinate, I would like to move the pipe from, let's say it was, this is the pipe, kind of messy, but there it is. I want to move it down. That's adding to the y coordinate. So I'm going to add half the height of the pipe. So we're going to say, take the current y coordinate and add half the height. So hey image, what is your height? And then divide that by 2. So here we're adding half the pipe's height to the y coordinate. And let's see if this is working properly. Oops, I died. It's looking pretty good. There's nothing awkward here. Let's go check. It's working, but something else is kind of awkward. Greenfoot image, get image. Okay, got it. This shouldn't be here. I'm doing this in the wrong place in the first place, so my apologies. Let's back up. Let's keep this the same. Cool. The place we need to do this is where we created the actual pipe. So in the world, so go to the world code, and in there, remember when we created the object? This is where you need to do it. So let's go here, and we're going to ask Pippy the pipe what it's, so first ask Pippy, hey Pippy, please tell me your image. That returns Pippy's image into an image object, and then we can ask the image object what its height is. So plus image dot get height, and then divided by 2. That's half the height. Okay, so let's just make sure this works, and then we'll go back and explain the code. Alright, there it is. So we've moved each pipe down by half its height. So the pipe used to be right here, the full height, and we basically moved it so that it was basically down here, and everything got shifted down by half a pipe height. So now we're in this situation. Cool. So back to our code. Alright, we created a new pipe every 100 act steps, and then we asked that pipe, hey a pipe, what is your image? That returned an actual image, and then the image we can ask, hey image, what is your height? And we took half. So that's the proper place to add this stuff. Um, Right. Our next goal is to, since we have pipes up there, if Flappy Bird touches a pipe, then it's game over. So let's add that functionality. So back here, let's do this in, we can do it several places. Let's go to Flappy Bird. So we'll do this in the Flappy Bird code. We can do it several places, but since we're talking about Flappy Bird itself, let's just do it there. So in the Flappy Bird's code, we have Flappy Bird, we set its location here. So first let's set the location and then check the location where we are. So first, this basically moves the Flappy Bird to its new spot, and now we'll say, hey, if we are touching a pipe, if we are touching a pipe, then game over. Alright, let's add this code. How do you find out if we are touching another actor? Well, let's go to the actor API and see. Here's the actor API. Let's look for a function that will help us. Um, Here's one. Get intersecting objects. This returns a list of actors. We could use this. I don't want to, but it's a better choice. In fact, these all return lists. The easiest method to use for now is going to be this one. Get one intersecting object. So the way this works is you call the method, you pass in a class type, like in our case, type.class. Then it returns the actual actor you're touching. So let's use this, and we'll explain it as we're doing it. So if we are, so call it get one intersecting object, we have to pass in the class type. For us, it's called, it to be pipe.class. And then if this equals, well, this, if it doesn't, if it's not null, so this you know from code HS by doing get element act. So if we are touching a pipe, this will return an actor. If it's not touching a pipe, it will return null, which means not existent. So if it's not null, that means it is something. So in this case, if we are touching something, then game over stuff. So we have code already for game over here. Let's copy this and paste it here. And oops, I pasted it 3 times apparently. Alright, so I've copied my game over code, and now let's see if when we touch a pipe, if we're touching something, then game over. Let's go check it out. Okay, compile, run. So things are fine, and if we touch a pipe, boom, game over. Cool, try this again. I'm scrolling along, and boom, hit a pipe. Awesome. So this is totally working. One more time, we try dropping down. Excellent. Now there's some space here, but you know what? For now, don't worry about that. We'll fix it later. Okay, onto the homework. So I'll set you up to do this and be able to continue on your own. When a pipe is created, we want to move it so the top of the pipe is at some random height between the bottom of the screen and somewhere above the middle. What I mean is this. So instead of the pipe being here, where it is now, you want pipes, like some pipes are down. It's not letting me move it. I don't know why. That's too bad. Alright, let me try this again. Blah blah, and we're dead, cool. So my point is some pipes are taller, some pipes are shorter. So what I want is, I want pipes to be able to be somewhere way down here. Other pipes are taller, and so on. So instead of being spawned at the halfway point, oh actually no, there's another thing we need to fix actually. Alright, no, this is actually good. So let's get our pipes into a position. So back to our Flappy world here. Alright, Currently, it's the halfway point. Let's move it the entire height here. If we do this, you won't see the pipes because the pipes are going to be created way down here off the screen. And to verify that, let me show you and like just subtract like say 20. You'll see the pipe peaking up by 20 units. Let's see this. So this pipe is peaking by so 20 units. You can see 20 units of it. So here's your goal for the homework. Modify in the world code. Modify this code here, in fact actually this part, so that the pipes are some random amount. So some pipes will be, let me time, okay? Your goal is you want some pipes to be really short like this. Other pipes should be taller. I can't grab it, so let's do this by hand. Some pipes should be taller. Some pipes should be even taller. You want to pick a random number that represents this distance right here. And that distance goes from either 0, which means flat down here, up to whatever you choose. It's your choice there. But you need to generate random numbers. So here's some hints. Under the Greenfoot class documentation, the Greenfoot class, inside here, there is a function, you got to find it, that will give you back random numbers. So use that random number function in combination with what the code you already have to make pipes appear at different angles when they spawn. Then, once you have one pipe on the bottom that's able to adjust itself up and down, define a variable called space between pipes and add a top pipe that's this far above the bottom pipe. That way you'll have this sort of feature. Let me actually open up my other program. So here's what I mean. When you run the program, you can see here that there are, and ignore this this top of the pipe for the moment. Just for now, we have simple pipes. So the bottom pipe is, there's one here that's a random height. There's one down here. Then on top of that, there's this spacing. To find this space to be some sort of constant, some global variable. And on top of that, spawn another pipe that sticks up. That way you always have two pipes, one on top and one on the bottom with this constant space in the middle. And remember, so down here, this is some random number that you've chosen. Let's put random number that you've generated and chosen. And then this is some constant, C. So that's your goal for the homework. All right, see you tomorrow, and good luck.